Hi everyone, and welcome to the CSESOC workshop going through MongoDB. My name is Jasper, and I'll be your host today. So a bit about me: I'm a second year software engineering student, member of the CSESOC subcom and tech lead on the CircX team of Enactus UNSW. Thanks everyone for coming, and I hope this workshop is useful for you all. So we're going to go through a couple of things today, firstly being what MongoDB is, its advantages, disadvantages, when to use it. Then we'll go through using MongoDB with an Express.js backend, and I'll be happy to answer any questions you guys have. Just post them in the chat and I'll get to them as we go along. So we'll start with what MongoDB types of databases used: relational databases and noSQL databases. So relational databases are comprised of multiple different related tables, and they're queried using SQL, or structured query language. Relational databases were created around 1970 as an improvement to flat file storage through being more efficient and secure. They're suited to storing important data with no room for error, like financial transactions. The database's course Comp 3311 covers these in detail, so we won't talk about them much today, just how they relate to noSQL. NoSQL databases are pretty much databases that don't use SQL, which is the basis for making queries to relational databases. So hence, data is not stored in tables, but in other forms. They're more suited to storing massive amounts of data with a need for high performance. NoSQL databases have four subtypes: document-oriented databases, column-oriented databases, graph databases, and key-value pairs, which is what MongoDB is. The key-value pairing structure is very similar to JSON. I would assume everyone here is familiar with JSON, but if not, here's an example. So our key here is first name, and value is Bob. Hence, the type of the value is string, but it can be anything like a number, a list, another bit of JSON, or null. MongoDB stores data in JSON-like documents called BSON, or binary encoded JSON, which is just an extended version of JSON and supports more types. This is then organized into collections which can be queried. And these collections can be thought of as the equivalent of tables in a relational database. In contrast to relational databases, we do not need database schemas, which can formally describe how the data is structured. This gives us a lot of flexibility when it comes to structuring our data. So NoSQL databases like MongoDB were developed around the 2000s by a company needing to store high amounts of data very, very quickly to keep up with high website traffic. Most of their data was being stored as JSON in their code, so they came up with the idea of producing a database which was JSON-like. As NoSQL was designed to solve the problems of relational databases, the advantages of it are just solutions to past problems. Firstly is the flexibility of data structure. A data schema is just a consistent way to query and describe data in a database. But the issue with relational databases, which require schemas, is that everything is linked between tables. So adding or removing something from the schema of one table can have a big impact on others, and you have to shift a lot of things around, which can be expensive and time-consuming. To tackle this, NoSQL databases are very flexible, and the structure of data can be changed very quickly, making them attractive to fast-moving startups, which always have customer requirements changing. The data in NoSQL databases also has no relation to other data, but if we're expecting to access different values, they're usually stored together. I'll expand on this a little bit later. Secondly is how the database is scaled. Once the capacity of a server is reached on a relational database, the only way to scale is by scaling up, meaning buying a more expensive, fancy server. MongoDB and most NoSQL databases instead allow for horizontal scaling via sharding. This is the idea of splitting up data between multiple physical servers, allowing for capacity to be increased without too much investment. Think of this as increasing capacity by adding more servers, not replacing the current ones. This also means that when working with MongoDB, as they're a cloud-hosted database, you don't have to worry about how your database will scale. They handle it all for you, and you can still maintain performance even with petabytes of data. Third is the speed of the queries. Complexity in relational databases can have a huge impact on performance, as data is stored across multiple tables and locations. So to make a query, it must pull together data from many different sources. However, in NoSQL, we can store data which is frequently accessed by an app together, so we only have to look in one place to get everything we need. This is the equivalent of buying from IKEA and having to assemble the item together, or buying it already built. MongoDB is shortened humongous, like the middle section of humongous, which is a bit telling that it's designed to handle humongous amounts of data while still maintaining performance. Lastly, MongoDB maps its data to popular programming language structures like JSON or Python dictionaries. This makes it easy for developers to change the data in their code and reduces the number of dependencies in a project, which is always nice. It also just makes getting MongoDB integrated into a project really easy and intuitive. While there are some big advantages to using a NoSQL database, there are certainly some downsides too. A big plus to using relational databases is that they've been around for so long, so they've been standardized. As mentioned, SQL is the standardized programming language which makes queries to relational databases, and there have been many database systems like MySQL and SQLite which help with the management of the database. Unfortunately, since NoSQL databases have not been around for so long, there is no standard equivalent to SQL for the form they should take. This can make it harder to decide which NoSQL database you should use. NoSQL databases can also be unstable and tend to follow the base principle, which means basically available, soft state, and eventual consistency. This means that ensuring the data is consistent, atomic, and available is a secondary priority under scalability and performance, and is not ensured by the database. But in a relational database, it is. Relational databases follow the ACID model, guaranteeing atomicity, consistency, isolation, and durability. This ensures that each query either fully succeeds or is fully rolled back. Data written is valid according to predefined rules. Concurrent queries don't contend with each other. And once committed to a database, data is considered permanent. For example, say we have a relational database used for handling financial transactions. If we want to record a transaction, the database will only return a success if the transaction was valid, it was entered into the database, and the data was validated as existing in the database. However, if we were doing this with a NoSQL database, it would be slightly different in that once a transaction is sent to the database, it will send a success once it has received data, as opposed to checked it is in the database or is even valid. So if there are any errors in the database, we need to manually check for them, which means it is then on the developer to ensure the data made it into the database. So if that was confusing, sorry, but just remember that NoSQL databases will assume they work, but relational databases will check their work. And so due to this, NoSQL databases can be unstable and may have less functionalities. Facebook, for example, uses a NoSQL database for a lot of their data storage. But have you ever noticed that sometimes a post you just made would disappear for a bit then reappear? Or your whole friends list won't show up, or some other glitch like that? This is due to the trade-off they made between performance and scalability compared to data consistency and reliability. Similar to this lack of standardization is an inability to work with SQL instructions. In an ideal world, we would be able to use SQL to query NoSQL databases, to sort of get the best of both, a standardized language and fast big data management. Fortunately for us, the people at MongoDB are very smart. They've been supporting an ACID model since they were started, giving you more confidence in your data being correct and reliable. However, this is not available with all NoSQL databases. Another issue with NoSQL databases is that they take up a fair bit of storage space. This is mainly due to sharding, where data is split up over different servers. With this comes a duplication of some nodes to make them accessible from all locations. So from one point of view, this is good, as it means data can be stored in multiple locations, and for someone to access it, they only have to query the next server. But it also means that you take up a lot more space. Can you find specific information with NoSQL, like how you can query SQL? Yes, you can query NoSQL databases very effectively, and we'll get to that very shortly. Which one is better between the two? So relational databases are more suited to structured data, which is clearly defined by relationships. Think banks keeping track of customers and transactions. Everything is very normalized and predictable. This is often for older applications. There are definitely times where relational databases are required, but for applications with unexpected complex data like text posts, social media friendships, which would require a graph, and other forms of media, NoSQL is superior due to its flexibility and ability to handle complex data. And it just so happens that most data today falls into that category, being unstructured and complex. And of course, noSQL should be used for times where there are high amounts of data needed. This could be something like personalizing the feed someone sees on social media. A lot of data is needed to ensure they're getting shown things relevant to their interests. But the reality of noSQL databases versus relational databases is that there's never going to be one which pushes out the other. The same as a lot of other battles like Vim versus Emacs or Java versus C++. They're both very well suited to certain use cases, depending on how your data is structured. Something that works great in a relational database might be slow, cumbersome, or a lot of work to implement in a noSQL database, and vice versa. A lot of new database systems have come out trying to blend together the technology from both, so to keep up with it, it's important to understand the fundamentals of a noSQL database and a relational database. So let's start on the demo. Hopefully that gave you a little bit of an intro into MongoDB and you understand a little bit more about why it's good. What you'll need for this tutorial is Node.js installed, preferably the latest version. Also need an API testing tool. I'll be using Advanced REST Client, but this is only available on Mac. If you're on Windows, Postman will do the same thing. We need this because we'll only be creating the backend of a course review website, and this will be the only way for us to interact with it without building a front end. Tim Zhang has done a great intro to React UI UX design, which you can find on the CSE Soc YouTube channel. Is noSQL faster than relational? In some cases, relational can be faster, but if you're doing big data management, often noSQL is a lot faster. But it definitely depends on how you structure your database. So the benefit of noSQL is that you can store all of your data together in one sort of, you can think of it like a dictionary kind of section. But in relational, you have to use joins to join together different data from different places, which is why it's a little bit slow. So let's start with the demo. Firstly, go to mongodb.com, just their standard website. Click sign in, and if you have an account, sign in. If you don't have one, then create one. It should only take a minute, and I'll just talk through what we'll be doing once we get here. We're going to use a package called Mongoose to connect to MongoDB with our Express.js backend. And Mongoose is really good because it provides an abstraction layer on top of MongoDB that eliminates the need for us to name our collections. We instead create collections using models. These models also perform the bulk of the work when establishing default values for document properties and ensuring our data is valid. Yes, cool. And so our database, when using these models, becomes very close to ACID compliant, giving us confidence that everything is going to work nicely. Hopefully you've all made an account by now and have logged in. And you should be getting to a screen not unlike this. Just click on Create New Project, name it something like MongoDB Workshop, and click Create, and go Next. Then I'll be the project owner for this, Create Project. Cool. Yes, so there's that link to that React with Tim Zhang in the chat if you'd like to take a look at that. Takes a little bit of time, but now we're here. Excellent. Hopefully you guys are all up to this page as well. Now we're going to go build a database, choose shared, and AWS Sydney, but you can go anywhere. Probably makes the most sense to go for Sydney, hey? And create cluster. Now while we wait for that, take a few minutes for the cluster to be created. We'll get started on the Node.js backend. So open up VS Code, and I've just created a new empty folder, just on VS Code, in some arbitrary file somewhere. So now we're going to open up a terminal, new terminal, and in our file type npm init. This is just going to set up a standard sort of npm JavaScript project. Name it MongoDB Workshop, version 1, description, using MongoDB. Entry point index.js, make sure you keep it as that. Test commands, don't worry about that. Git repository, don't need that. Keywords, don't need that. Author, Jasper, du, Francesco. License, don't need that. Is this okay? Looks good. Excellent. Now we've got that, we want to install npm install Mongoose, Express, and .env. Mongoose I've talked about. Express is just the Node.js backend framework. It makes it really easy to create a backend in JavaScript. And .env is to ensure that our MongoDB login string is kept safe if we choose to put our code onto GitHub. Now we can open up a file called index.js, which is our entry point. Just check any questions, no. Which is our entry point, cool. And then we will start creating our Express server. So we go const express equals require, oh, I guess can't spell. Require express. Const mongoose equals require. Sorry, I really can't spell. Require mongoose and const dot env equals require dot env. Then we want to configure our .env package. So just call that command. Then go app.use express.json, and this will let us return JSON from our roots. And then oops. My bad. Need to do app equals express app.use express.json and app.listen on port 9000. That console.log server started and console.log. Port 9000. Cool. So now we have the basics of our backend started. Then we can just go node index.js and hopefully we should get these two correct messages telling us that it's working. Excellent. That looks good. Shift back to MongoDB and our cluster should have finished creating. So click connect and you'll see a screen like this. I'm just going to allow access from anywhere. And IP address, add IP address, anything. Cool. Username, my username is just going to be Jasper D. Password, don't use that. Don't want you guys to be able to see my password for it, but excellent. Then we will just create that database user. Excellent. Cool. Make sure you remember what this password is. Then choose connection method and click choose your application, connect your application, sorry. And this is the string that we'll be using. So you notice that it has your username here and then the password that you just used to create your user there. Excellent. So we'll copy this and we'll switch back over to here, create a file called .env, and into this create a variable called MongoDB connect. Excellent. And we're back. Nice. There you are. How is that? Hopefully that works a little bit. But cool. So created that. Almost done with connection. Now we just want to indent everything we have here and reference our Mongoose object and create a promise .connect with URL and add in this dictionary of what were the terms again? Use URL. Oh, I think to use new URL parser actually. So I've forgotten what the required ones are, but here they are. Type in this, use new URL parser true, and use unified topology true. The use unified topology true is just going to opt into using MongoDB's new connection management system. And then we use the then promise to execute all this stuff. Oops. There, copy that into there. And then, that's not how the then promise works. It goes like this, there, play that, and move that to there. Excellent. This is now our backend entry point, index.js. And if we then go into our package.json file, and under scripts, we write a start script and go node. So the start of this new import now happened. So we've now made a successful connection to our MongoDB database, which is excellent. Good start. Now, I know we said earlier that databases are nice and they don't need schemas, but schemas are very useful. And Mongoose lets us create a schema for our data using models, which are kind of like objects. So let's create our first model, which will be a model for review. Now we're going to create a folder called models. Oops. Models, and within our models we'll create a file called review.js. Oh goodness, what's happened there? Review.js, move that into our models folder. Cool. And then go const mongoose equals require mongoose again, and create a schema. So their schema equals mongoose.schema. Create a schema like this: author, string, subject, string, rating, number. And so these are just all the fields that we want to create a review for a course website. So you want whoever wrote it, you'd want what the course code is, like com1511, and then you'd want the rating out of 5, and we'd want content, as in what they wrote for the review. Finally, we'd want a date for when they wrote it. So now we've made our first schema, and you can see it's pretty easy to make. And all we need to do is module.exports equals mongoose.model review and schema. This is just making the module available to our other files. Cool. Notice that none of these notice that none of these fields are going to be unique or guaranteed to be unique. In a relational database, we'd have to specify a primary key for each table, but here we don't. This is because a unique object ID is assigned to each document when it's added into the database, which is very nice. Now we're going to start creating our routes. So we'll create a new file called routes.js, and we will do const express equals require express, and const, or is it review, I think, like so. Const review equals require dot slash models slash review, and const router equals express dot router. Then skip some lines and do module.exports equals router. Awesome. And this is pretty much the skeleton for any backend route file that you make with Express. Very simple. Nice and easy. The first one that we're going to make, first route that we're going to make, is to get all of the reviews in our database. And so we'll do this by making a get method, so router.get/reviews, async, so request and response, and then using our nice ES6 syntax, do that, nice. Skeleton for a get request to the reviews route. Then we'll do const reviews equals await view.find empty dictionary author subject rating content. Now this review.find method, so we're referencing the Mongoose object review or Mongoose model review. Then we're using .find, which is another function given by Mongoose to us, which just lets us find things in the database nice and easily. And because we've put nothing in this dictionary, it's just going to find all of them. So it's going to find all of the reviews and give us back these fields. Then we're going to set respond with this, create a dictionary, list, posts, and because this .find method is going to return a list, we can't just return a list straight from a root, we have to return it in JSON form. So then there. So list posts and posts. Excellent. Now if we save that, go back to our index.js file, we have to route. Going to import our routes. Forgot to do this earlier, but that's okay. Easy. Cool. And const routes equals require ./routes. Excellent. Now if we close that, start this again, we should be successful, and if we start our advanced REST client or Postman for whichever you choose to use, oh goodness, we will then go to MongoDB Workshop reviews and get all reviews. If we send this, oh no, yes, oops. There we go, cool. Back to our advanced REST client and send it to, oh yeah, sorry. Getting a bit jumbled up here, that's okay. Press it again and we see we get back this list post dictionary and an empty list, which is awesome, exactly what we're expecting. Naturally, what we want to do next is add a review into our database. So that's going to be by creating a post request. So router.post to, again, same URL, reviews, and asynchronous request response. There, and here we go. Now we go var d. This will be our new date. I want to keep track of when we're putting it in. And now we'll construct a review. So we'll go const review equals new review. And it's just saying new body for it. And copy paste this in. Excellent. So then these fields, see we're filling up the author, subject, rating, content, date, and that aligns with our review object. We've got the author, subject, rating. Oops, forgot to add in content. Excellent. Nice. So now I've constructed this new review object. All we have to do now is commit it to the database. And so Mongoose provides us a very nice way to do that. And it's just one await function review dot save. And so then this review dot save will save this review to the database. Just a nice and easy way of doing it. And if I just check if I'm missing anything, don't think so, except for the response. And every route needs a response. Good. Good. First, you can see I've instantiated the new review object, put some values into it, and then use the async function review.save to commit it to the database. Now this isn't the only way to add things to the database. There are a few other functions like review.create, which can do it in one line, and you can just, or you could use review.insertMany, which will insert a list of reviews. But I like using the save method just because it's clear where we've instantiated the object and where it's being committed to the database. So now let's try adding a post to the database. So we'll go to our create review, and I've already got one written out, and this is by author Gene, subject comp5111, comp1511, rating 3, this is a good course, and the date. Date we don't need to include because that's being done automatically for us, which is very nice. So now we'll end this one, restart our server, oops, save this, and restart our server again. Switch over to our advanced REST client, and send that. Excellent. Looks good. Now we can see, if we go back to get all reviews, we send another request, and it appears, which is lovely. So if we add a few more, let's say Jasper reviews something, and I also reviewed comp1511. I gave it a 5. I thought it was great. Then post that, and let's say James did another one, and he did comp3141, rating 5. This is a good course. Cool. And he also did one for comp1511. We'll just be using this data later for some examples. Cool. Excellent. And of course we can test that, get all reviews. Oh my goodness. Almost there. Cool. And then we can see they're all shown up in a list, which is lovely. Now we want to be able to search reviews by subject code and for author, but only with one search term. So we're going to create a searching route, or route. So I want to be a router.get at reviews find, and again it will be async with rec and res and this, that. Cool. I'll create const reviews, which is the ones we'll find, which are equal to await review.find, and this time we're going to put something into this bracket, and we're going to put an OR. This can be an OR, and then give it a list, author rec dot query dot, oh goodness, search term, excellent. Author rec query search term, and then also want to pass it subject rec dot query dot search term. Cool. And then that will just we'll tell it again what we're looking for, and again we're looking for author, subject, rating, and content. I'll paste this back in here. So hopefully you guys can all see that. And it's going to be review.find. This OR will just mean that it matches against both this author being equal to search term and subject being equal to search term. So this just means that we can search for either author or subject just by giving it one search term, which is nice and convenient. Then again, with the response, it'll be ref.send list reviews. Cool. Cancel that, npm start. Go back to our advanced REST client and search for a review by course. We go reviews, find search terms, Jasper wrote a review. So you can see we're making this request to this URL where it matches up with the reviews, find, and then after that, this question mark just means request.query. Then search term equals Jasper. Send that through and we get back Jasper. I only wrote one review. But if we wanted to find all of the reviews for comp 1511, then search for that again, and we'll see we get all the 1511, regardless of name. And you can see this is quite useful. It's been very useful in implementing a simple search function with Mongoose. And they handle everything for us. And also means that we're not requesting all of the reviews and searching through it ourselves, because that can get pretty time consuming and slow trying to send back a lot of reviews. But we just get the database to handle it for us. Cool. Now we want to be able to retrieve a specific review. So we're going to make another GET request. And we'll make this one to reviews/review ID. Let's check any questions. No, cool. Making this request back to reviews review ID. And this little bit here is known as a slug. And it pretty much just means that it can be anything except when naming it something, if that makes sense. We're just putting a variable into our URL. So it would mean that if we're, where is it? Like this. We were just passing in an object ID into reviews. So you can see it sort of lines up there. Hopefully that makes sense. If it doesn't, then we'll get to it. Excellent. So another async function, request, response, and there. Now we want to use a try catch block. So in our try, we will have const review equals rec.params.review ID, specifying it here. We can name this anything, name that anything, doesn't really matter. Sorry, here we go. Can be mixed up here, but that's okay. Review dot find one, and we use this function find one, and then we're going to specify that underscore ID is that, and again we will give it that and look for the author, rating, subject, and content. So this again referencing the review model and the find one function, which will only return one, hence the name. And we're looking for the ID being able to request params review ID. So we're just searching for where one of the models has a review ID of this review ID. Sorry, one of the models has an ID of this review ID. Hopefully that makes sense. And find one will return an error if it doesn't find one. If it does find one, then it will just carry on. So then we want to do res.send, our response.send, and review. It'll only send just the JSON, so we don't need to put it into a list or anything. And of course, every try needs a catch, which means that if there's an error, res.set, I think it's res.set, res.status. Res.status 404 not found, and response.send error post not found. Excellent, excellent, excellent. Looks good. Let's restart the server and try it out. npm start. And in our get all reviews, we were given this review ID, so we'll copy and paste this one into our search for review, get specific post, put it into here, and then we'll make the request. And we'll see we get back our review from Gene, comp 1511, this is a good course, and also gives us the ID. Now, I should probably also mention that this string actually does do something. It's not just there for no reason. And so if we add date in and then restart our server and make the exact same request that we just did, we're also given the date object, which is very useful. And it shows that you can specify what you're actually wanting to get back. So if you only want to show a preview of a review, then you could only ask for maybe author and subject. If you want to show the whole thing, ask for the content, but you wouldn't want to always ask for that because it just, you're passing more data over the internet and it slows down a little bit. But definitely ties back to the idea of noSQL being able to store data in the same place as in everything you access together in the same place, as opposed to relational databases needing to use joins to bring in data from different places. Hopefully that makes sense. Excellent. Now we want to be able to delete a review naturally if someone posts something that's a bit too mean and hurts our lecturers. So create a router.delete route, and delete route is going to go to reviews with a, sorry, my blank there for a sec. Review ID async rec res. Again, we're using this useful slug, which is great. Just this review ID slug being able to refer to it. And we'll just be making these same requests like here. Router.delete that. All we do for a delete, what we do for deleting from MongoDB, again, have a try block, and we just call the method on the object review delete one, which is great, and then in here we can just specify what we're looking for. So if the ID is equal to review ID, it will delete that one. If you wanted to, you could do review.delete many. If you want to delete everything, just put an empty dictionary in there and it will delete all of it, which is nice. That's convenient ways to update the database. And Mongoose provides such a great package, would highly recommend looking into it more if you have the time. Then we're going to set our res.status to 204 and send, and this is just the success status, telling us that we successfully deleted the review. What is that for? And then every try needs a catch. And here, status, again 404, not found, and res.send error per review, not found. Same as everywhere else. Oops, that should be a review. Cool, awesome. This needs to be in a dictionary as well. My bad. Ah. And that will just delete a review. If we wanted to update the content of a review, sorry, we're almost there. Two more rounds to go. Update the content of a review, perfectly reasonable. Someone might change their mind about a course. Fair enough. Now we create a patch request, router.patch /reviews /review ID, asynchronous function with a request and a response body, and another try a catch block. Here we go, variable review is equal to await review dot find one. It's just going to send off the object, which we find from the ID, which is this needs to be on rec dot params dot review ID. Rec dot params again dot review ID. Awesome, looks good. Love it. And review dot content equals rec dot body dot content. So in this patch review, someone's going to pass in like the post review, a body, and it'll just pass in an ID and a content, and then it will patch that review with the content. If you wanted, you could do an if statement, like checking if there's a rating in there as well, and then you'd update the rating. You could check if there's a author in there, you can update the author. But for now, we know there will always be a content string in there, and we're only going to update the content. Then again, using our very convenient save function as earlier, saves the database just like that, patches it, updates it, nice and easy, don't have to worry about it. Then response.send, and we'll send back the review. Again, every try needs a catch. Status 404 not found. Res.send, getting a bit repetitive, isn't it? Error. Post review not found. Awesome. And that's our patch route to update using the review ID. So this is another reason why I like using the save method, just because it's nice and convenient to update something in MongoDB. And then using it everywhere just gives a bit of consistency. Like when you're creating a review, using the save method, if you're deleting, not if you're deleting, but if you're updating, using the save method is also good. But you can mix and match and use create or create all, or create multiple if you'd like. So we've gone through a few different things here, such as getting all of the objects in a collection with our get request here, posting and creating one to our database, but now I'd like to introduce you to aggregation pipelines, which are extremely useful. I found them quite tricky to wrap my head around, the semantics of them, but once they make sense, they're very, very useful. And when chained together, they can make MongoDB do all of the heavy lifting for you, while your backend looks nice and sleek and minimalist in how much code there is. I would highly recommend looking into aggregation pipelines after this if you have time and if you're interested. And we actually did use an aggregation command earlier with this OR, this little OR. So this OR is an aggregation command, and it just lets us adjust what kind of request we're making to MongoDB. Cool. You can think of aggregation pipelines as being declarative, which is kind of the idea behind the React framework. And so you specify what you want, but not how you want to achieve it. Similar to going into a restaurant, ordering the fish, as opposed to telling the chef how to cook the fish. Pretty common example, but it's just telling the database you want this data, not how you want to get it. But usually in your code, you would request all the data and then have to filter through it yourself. Firstly, let's create a new route, a get route, with some arbitrary URL, and we'll just make it specific search. Sorry, I lost my spot here. Yeah, cool. And we'll make sure that we put this above the routes that use slugs, because it'll match the slug before it matches this, if we put this down the bottom of the file. Make sure we got the specific search there, cool. And then async, and request, and response, and returning this, cool, excellent. Now, aggregation pipelines are split into stages, and so two very common stages are the match stage and the group stage. We'll use both of these today. So the match stage allows us to filter results. So let's try filtering results by checking if there are any comp 1511 subjects. So we want to create a dictionary called match, which is equal to match, set subject comp 1511. Then we're going to call the aggregate method on a review model. So we'll go const, var reviews equals await view dot aggregate, and inside this aggregate we'll call the match pipeline, and the match pipeline is then getting past the match dictionary. Put this into a list, and we should be good. Then the response.send review list reviews. Oops. Cool. Now passing this match, this is our aggregation command, and it's getting past a dictionary subject, and so it's going to match all of them where the subject is equal to comp 1511. So we'll save that, restart our sorry, I'll change this to aggregation actually, that makes more sense. Change this to aggregation, cool, and restart it. Excellent. Server started listening on port 9000, then we make a request to this aggregation, and it says error review not found, which is not ideal. Okay. Might actually move this up a little bit higher. So weird. Why isn't that working? I spelled it right, haven't I? Sorry, I've got reviews, but it should be here. It should be reviews. Okay, sorry about that, everyone. Slight hiccup. All good. Back to it. There we go. Now we send the request to aggregation, and we can see we get back any subjects that match comp 1511. Our next stage we're going to use is the group stage. And group stage lets us transform documents, combine them in fancy cool new ways. So now we're going to create a group dictionary equals where the ID is subject. So erase a little bit, and average of rating. And then count. Sum 1. This group is going to say, because we specified the ID, means that subject has to be the unique value. So then whenever it finds a subject of the same value, it'll squish it together. And then within those squished together groups, it'll find the average. And average, we just use the aggregation command avg. And this just refers to whatever the field of that specific model is. Then we've got the count, and we use the sum aggregation command. And this will give us the sum of how many of each subject there are. Then all we need to do is change this group and group. Now we're using the group stage. We'll make the same request, and awesome. We find that we get a list of reviews, ID comp1511, and the average is 4.333. And the count is 3, so we got 3 reviews, average rating of 4.3. And for comp 3141, average rating is 5, and we only have 1 of them. And you can see how easy this is, how quick it is, and just gets MongoDB to do all the heavy lifting. Last thing I want to show you is connecting aggregation pipelines together. Because they're in stages, it would make sense that we can do this. So we're just going to add another dictionary here, and we go match, and match. And put a comma there, a list of dictionaries, cool, restart, npm start. And make that request again, and we find we only get the comp 1511 with the average and the count. So we've seen that it is very useful for these stages to be linked together. And you can see you can do filtering pretty easily. You don't have to do it in your own code, you can just get MongoDB to do it. And we could have done the group command first and then the match, but the issue is the group will pretty much always execute on every document that's given, but the match will cut down the amount of documents that it's sort of transforming. So it's always better if you can do a match command first to reduce the number of documents being passed into the group, if that makes any sense. So imagine we're trying to do a sort. So then you'd first want to reduce how many elements you have to sort, and then you'd want to sort them. It won't make a huge difference now, but when you're working with a lot of data and a lot of responses are coming back from this, it can make a massive difference, the order that you put these stages into. So thank you everyone for coming today, and I hope that this was useful for you. I hope that you learned something from today. And if you want to go deeper into MongoDB and Mongoose, I would just try exploring it yourself, looking into aggregate pipelines and their full potential. You can look at geo-queries, and there are a lot of other MongoDB features which are very useful. So I hope this was a good starting point for everyone, and thank you very much for coming. If anyone has any questions, feel free to ask them in the chat. I'll stay around for another few minutes, just in case. Don't need that label. All good. Thanks for coming, guys. Thanks for coming. Hopefully it was useful. Okay, excellent. So yeah, if no one else has any questions, thank you all very much for coming, and have a lovely day.